All right. They say a picture's worth 1,000 words. Turns out it's actually worth 480 trillion. That's my dad joke for today. I hope you enjoy it. But this is actually a cool sort of slide that was from Google I/O about a week ago for those who were able to join in during the keynote of that session. It just speaks to unprecedented growth we've seen in the last year with LLMs, which is pretty bananas. If you asked me a few years ago when ChatGPT came out, if this is where we'd be today, I don't think I would have predicted this, but that is the world. Everyone, and that's why we're all here. We're all building with LLMs, doing cool stuff. But I think actually look at 2024, while there was crazy growth, the real story of 2024, it's the year when open source models started to really catch up with those closed source frontier models. And this chart was pulled in the middle of last year across a popular benchmark. It only goes up to LLaMA 3.1. We've obviously multiple generations past that now. But we started to see that these open source models were really starting to punch above their weight class and meet the performance of frontier models. Now, obviously, time has passed since then. We all remember the DeepSeek moment from earlier this year. And while there was a lot of, I think, noise around geopolitical sort of ridiculousness or the supposed low cost of training DeepSeek, the real narrative here for me, and I think for many of you, is that this model is really powerful and punches above its weight class, and it's open source. And it really just put even more power in the hands of developers everywhere and really made it possible that, hey, we don't have to rely on commercial models to do what we need to do to build incredible applications. And I think what's really exciting is whatever gap still exists between open source models and closed source models can easily be closed with fine tuning. So about a year and a half ago, we did this thing called Lorax. We fine tuned 30 plus of the smallest open source models, or 20 plus across 30 different tasks. So a broad set of use cases, fine tune them. Average cost of fine tuning was only $8. And what we're able to show is that 85% of those models were now either on par or better than GPT-4. So what that means is you get the economics of a small open source model. They're going to be faster because they're smaller. And now you're getting better performance than the best frontier models. And that was all done with fine tuning. So we're at a point now where whatever gap exists, you can beat it. And what's cool is we have things now today that are gaining steam again, like reinforcement learning or reinforcement fine tuning. And so you don't even need data to train your models. Now you can take a best of breed open source model with reward functions, programmatically train it to outperform some of the best commercial models out there. Okay, so I think, look, enough said. I don't need to tell you anymore. We're all here because we want to use open source models. We see the vision. Many of you are building with them. It just makes sense, right? But I think the reason we are here today is because, and what we're going to talk about is not all deployments are actually created equal. So look, we work with, at Predibase, hundreds and thousands of customers and teams, enterprise to small startup. And we see three common architecture patterns when it comes to getting started with open source LLMs and building production applications. It's kind of three paths forward. The roll your own crowd, this really is pretty few and far between. So unless, honestly, you're like the Ubers of the world and you have hundreds, if not thousands of the best engineers in Silicon Valley, rolling your own infrastructure, distributed training, and serving infrastructure for these large LLMs is really not easy or for the faint of heart. It's expensive. You have to have expertise. You have to manage it. So we don't really see this very often. And honestly, the people who do try this path oftentimes kind of move off it pretty quickly. It does give you complete flexibility, but it comes at a massive cost. Then we see the crowd who are using shared managed LLM endpoints. This is pretty common and what we're going to talk about more today. It's fast and easy, but the thing we want to share and sort of expose is that it actually comes at a cost. And there's a better way to do this without sacrificing those things that you're looking for. And that's private managed endpoints. This to us gives you the best of both worlds. So if you're really running a production job, you need SLAs and performance, you can do that with private endpoints. You get that flexibility, but it's still easy. It's still fast, and it's actually more secure. So we're going to go into that. I'm going to hand it over to the team now, the real experts, to talk about all the cool things that make that up. All right, Joseph, take it away.
Thanks, Michael.
And I'll stop sharing. That would help.
See my slides? Great. So when you think about comparing dedicated LLMs to the shared serverless approach, we like to think of there being four different issues or four different categories of problems that you might want to address. One issue that you experience with shared LLMs is loss of data control. So shared LLMs, you're running on shared resources, sharing your hardware with other people, your data is going over the public internet. For some consumers, that's perfectly fine. This is not a big issue. But some consumers have a lot of data integrity or regulatory concerns, and this is just not acceptable. Number two is pricing. So it turns out that when you compare shared serverless endpoints against private open source models, once your throughput gets high enough, dedicated models just end up being quite a bit cheaper. And with the ability to fine tune our models to your data, you can get cheaper performance with equivalent quality on a dedicated model. The third issue we think about is inflexibility. So with a shared approach, you're restricted to the endpoints and models that a shared serverless provider lists, and there's the fine-tuning techniques that they might make available for those models. If you have some sort of obscure or non-standard model, you're just out of luck. You're not going to be able to serve these models using a shared serverless approach. And finally, the final issue we think about is reliability. So with shared deployments, you're running on shared hardware. That means you're competing for shared resources with other people. You have noisy neighbor issues, queuing, latency can be unpredictable. And so you might experience rate limiting as a way to solve these problems. And roughly, just generally speaking, your performance is not as predictable as it can be with a dedicated deployment. So what do we think about as the solution to these things with dedicated deployments? For data control, dedicated deployments are private and secure. You can run LLMs on dedicated hardware, so you're not sharing it with anybody else. And you even have the ability to run LLMs on your own hardware managed by us. So your data never even leaves your own cloud. Economies of scale. It turns out that dedicated deployments, fine-tuned to get equivalent quality, are quite a bit cheaper in practice than comparable closed-sourced shared models. Flexibility. If you're spinning up dedicated deployments, you really have the ability to spin up whatever deployment you want, whatever model you want, whatever adapters you want, whatever modifications, parameter tuning, and tweaks that you want that make sense for your problem domain. And finally, with reliability, well, you've got your own hardware. Nobody's sharing it with you, so you're not going to experience noisy neighbor issues. There's no rate limiting. You get dedicated support and guaranteed SLAs, which you would not normally have with a shared serverless approach. So let's talk a little bit more about privacy and what that looks like. So like I said, with a shared deployment, this is what your life looks like. You have a shared LLM out there, which is living in your LLM provider's cloud, and any customer who uses a service is talking to these same deployments. So your inference data, your prompt requests, your prompt responses are all getting handled by these same GPUs. Again, that's fine for some customers, but if you have like high data integrity constraints, this is not acceptable. So there's two things we can do on top of this to improve data privacy. The first very straightforward thing is just dedicated deployments within your LLM provider's cloud. So now you spin up a deployment, that deployment is yours, only your requests ever go to that deployment, and nobody else, no other customers will see it. So your hardware is segregated and your data is segregated. But if you want to go a step further, you can spin up what's called a VPC. VPC, I'm sure many of you have heard of. This is a virtual private cloud, but a VPC is your own cloud, your own hardware. And companies like Predibase offer the ability to create VPCs for you, serving your own LLMs. So we manage the LLMs for you, but they live on your hardware. You control them, you own them. And so in this case, not only is your data not shared with other customers of the LLM company, the data is not even shared with your LLM provider. Like this is your data on your hardware. So that's thinking about the hardware. And let's talk a little bit about the network path that the hardware takes. So when we talk about two concepts I'm going to introduce, many of you are probably familiar with this, is the idea of a control plane and a data plane. So data plane here is just where your LLMs live, whatever cloud that happens to be in that's serving prompt requests. And the control plane is something that a company like Predibase would maintain that's responsible for orchestrating. So creating deployments, tearing them down, stuff like that. So I just want those two concepts to be familiar with you. So to thinking about the flow of data, thinking about shared LLMs, when you're sending inference requests, you have an LLM that's up in a shared up in some sort of shared endpoint. When you're sending prompt requests and getting back the responses, the data that you're sending is flowing over the public internet. It goes from your computers off through the internet over some backbone, and eventually it ends up hitting your shared shared provider, and then hitting a shared deployment and coming back to you. So this is not super secure. Like, your data is just now flowing over the public internet, and for some customers, that's a not acceptable level of privacy. So what level of data isolation can we get that's better than that? Well, with a standard VPC, you have a world that looks a little bit more like this. So now you have your application servers that are handling your own customer logic. You have your VPCs, your LLMs in your VPC. So this is running on your own hardware. So at least all of your servers are now in your own world. But you still have data going, inference requests in this case, going from your application server through a control plane to the VPC and back. So this is better. Like, your data is now going just through, in our case, Predibase's servers and Predibase's networks. But there's still Predibase in the middle. If you're particularly security concerned, companies like Predibase offer something called direct ingress. And what we do with direct ingress is we can set up a direct communication link from your application servers to your LLMs. So whenever you make an inference request, your application servers and your VPCs, which are presumably living in the same region, can communicate directly with each other. All inference requests go directly from your host to your LLMs and back. There is no intermediary. Your data doesn't even get seen by Predibase or any other inference company. The only things that Predibase is doing is sending control messages to your VPC saying, like, create a new deployment, tear down this deployment, stuff like this. And stuff like your training data that you might use for fine tuning also only lives in the VPC and never leaves the outside world. So this is about the biggest amount of data isolation you could possibly get, which is something available with dedicated deployments in VPCs and definitely not in a shared environment. So that's what we think about with privacy. Thinking a little bit about cost now, there's two things to think about cost. One is that, broadly speaking, that open source LLMs are just cheaper in aggregate than closed source shared LLMs, especially at high volume. And the second thing to think about is it's possible to tune your costs to your needs. So if you are somebody who's very latency sensitive and you're willing to spend more money, you might want to spin up a dedicated deployment on an H100 to do whatever you need. But if you're not so latency sensitive and you can afford low cost, you can pay for cheaper hardware. You can pay like a fifth as much for an A10G or something like that, if that's an acceptable use case for you. So you have flexibility here to tweak your cost spend to your needs. Looking at a cost analysis, here's a simple cost analysis comparing a dedicated LLaMA 3.1 instance running on an H100 against GPT-4o. So the x-axis here is just requests per second. And these requests, when we generated, we assume there were roughly 800 tokens input and 50 tokens output, if that matters. And the y-axis here is the annualized cost you would expect to see for these two different serving approaches over the course of a year. And as you can see, you're roughly 2x cheaper serving a dedicated LLaMA 3.1 over using GPT-4o. And you might notice, of course, that like we're comparing LLaMA 3.1 to GPT-4o, the model quality might be different. But the thing that Michael pointed out earlier is that with fine tuning for your domain, the quality that you can get from a dedicated LLaMA 3.1 can be comparable to or even better than a GPT-4 instance. So you can get same or better quality, faster performance for half the price with a dedicated deployment that you can fine tune for your own needs or for your own data. Think about reliability. This is stuff I touched on before, but when you pay for a dedicated deployment, you set up a contract for dedicated deployment, you get an SLA. You get guaranteed uptime. You get dedicated support who helps you if your deployment is having issues. If you're having trouble figuring out how to do something, you don't get that with a shared serverless endpoint. You just pay for what you get. It's your own deployment. There's no rate limit. You can hit this thing as hard as you want and get the like maximum possible capacity from it. And as I mentioned, you have support. And this is just a simple GIF that shows some of the issues you might have with performance on a shared deployment. So this is showing a queuing thing. So what we're seeing is Dan here is queued a number of requests on a shared deployment. Then Celia and Tony and Anna came along and queued some requests. And they're later, so they have to wait for Dan's request to complete before their own come in. So this is just illustrating the issue of a noisy neighbor deployment, leading to inconsistent or unpredictable latency in a shared serverless environment. So I'll talk a little bit about performance, and I want to go back to VPCs a little bit more, direct ingress, and explain some of the performance benefits you can get from setting up VPCs with direct ingress. So direct ingress, again, just as a reminder, is when we can set up a direct communication from your application server to your VPC. To your LLMs in your VPC. So in regular ingress, just thinking about the VPC case, although this also applies to shared serverless or a dedicated non-VPC deployment. Anytime you make a request, your request has to go from your application code to the control plane, which routes it to the appropriate LLM and sends the response back. That'll be if you're sending it to some dedicated deployment or some shared serverless deployment somewhere else. The point here is like before your request gets to your VPC, it has to make some number of network hops. It has to go through the control plane, which processes the data, and it has to do that all again on the way back. So the number of additional network calls and overhead that happen between you and your LLM. By contrast, direct ingress really is just your application talking directly to your LLM. So you've eliminated the network hops from your application server to the control plane to the LLM, any work that the control plane might add. It's really just talking back and forth between your application server and your LLM. Most likely, your application code and your LLM are co-located in the same region. So like the network hops here are trivial. This is just about as fast as it could possibly be. So as a simple case study, I wanted to show sort of the best case, or depending on how I think about it, worst case scenario for direct ingress. So what I did is I looked at a setup where we have our VPC, our control plane, and our application servers all running in US West 2, AWS US West 2. And I wanted to compare the latency of regular ingress connection, which goes through the control plane, versus direct ingress. And you can see here, like regular ingress is about 55 milliseconds time to first token. So that's just 55 milliseconds till you start seeing a response back from the LLM. And with direct ingress, you see about 50 milliseconds time to first token. So that's about a 10% reduction in cost. And the thing that I want to emphasize is like, this is the absolute worst case for direct ingress. Like everything is co-located in the same place. All your network hops are just from US West 2 to US West 2. That's really not much, but even with that, you see a 10% reduction in latency. But in reality, your VPCs, your application code are not necessarily going to be in the same place as our control plane. Why would they be? And depending on where you are, you can add significant additional network latency on top of this. And on the right here, you can see this graph of additional latency that you might expect. So if your VPCs and your application code happen to be in US West 1 instead of US West 2, every single arrow that I showed on that previous graph is adding an additional 22 milliseconds of latency. And remember, that's 4 different arrows. Like it's your request to the control plane, to the LLM, back to the control plane, back to US West 1. So we're talking, dozens of milliseconds of additional latency and network hops just because you have to go through the control plane. That's US West 1. If you happen to be in the EU, you're talking 150 milliseconds of latency. And if you happen to be in India, we're talking like 220 milliseconds of latency for additional requests. So the performance improvement you can get from direct ingress can be really substantial. All right, I'm going to hand it over to Jeff now, who's going to talk a lot more in detail about performance issues.
Yes, thanks, Joseph. So for the next few minutes here, we're going to be talking about how you can customize your private deployment to meet your throughput and cost needs, and a few other considerations that can help you manage quality as well. So here at Predibase, we work with a lot of different customers with many different use cases, different needs, different requirements for their uptime or for the amount of traffic that they can handle. And so we work with cloud providers to offer a wide range of accelerators to host your LLMs on. This is sort of the first, most basic decision you have to make when setting up your private deployment beyond which model you want to use, is determining which hardware to run it on. So in order to give you the most flexibility possible, we provide a variety of accelerators with some with settings like floating point 8 compatibility, with a variety of memory capacity, a variety of other options that you can select through either our product to tailor them to your needs. So these can range from smaller hardware like the A10G or the L4 in VPC. These would allow you to host smaller models, maybe models with lower demands in production, all the way up to A100s and H100s at our enterprise tier, give you the ability to run larger models in production, to use a wider range of models. And we're always looking for the next for the next hardware to add. So we also upcoming have H200s and MI300X. To give you an idea of how to balance throughput and cost for your hardware selection, we ran some tests with LLaMA 318 billion instruct, just running 800 input tokens, getting 50 output tokens through a few different GPU offerings that we have. And at the lower end, you are paying the lowest cost per hour. You're getting about 500,000 tokens in that time. Sort of the max throughput that if you were using the GPU to its fullest extent. And at the higher end, for only about 1.5 times the price per hour, you are getting 7 times the tokens that you would be able to process in the same amount of time. Again, if you're using the GPU to the fullest extent. And notably, with L40S, you are at plus floating point 8, you are getting performance comparable to an A100 for almost the same price, for only a little overhead over the A10G, over the lowest cost that you could select. So that is a good trade-off between cost and latency. Next. But beyond just raw throughput that you can get from the hardware, from the data type that you have selected, one thing that we have made to make your models faster is a turbo speculator. We call it Turbo. This is a small set of weights that are added to the base model that you can train on your data to predict additional tokens. So typically, when you're generating text with an LLM, you're generating 1 token at a time, just the next token in sequence. With speculation, you can generate 2, 3, 4 tokens at a time, and that will give you, in our experience, that will give you up to about a 3 times increase in throughput for very little extra cost in terms of memory usage or compute power needed. And they also go on top of adapters. So you can use both LoRa and Turbo to improve model quality and model throughput. Next. To give you an idea of the types of increases you can see using FP8 and Turbo FP8 where available. We ran some tests across all of our GPU offerings, and we found that in general, with FP8 and Turbo, you are looking at, in general, with Turbo, you are getting a 2x increase in throughput over a base FP16 served model. And if you if FP8 is available and you use Turbo with it, you're getting a 4x increase in throughput over up to 4x increase in throughput over the base model served at FP16, and that is quite a bit of improvement for very little cost and effort on your part. All you have to do is train up a speculator on your data using the same fine-tuning tools that we already provide. Next. Yeah. I mentioned also that you can use LoRa's to improve model quality. Well, so you may have multiple use cases. Let's say you have two different question and answer models that are working with different different knowledge bases, right? You would normally potentially deploy this as a set of two deployments, one with each LoRa attached to it. However, this can be really inefficient, and the good news with Predibase deployments is you don't have to do that. You can have a single deployment with multiple LoRa's attached to it. Yeah, so our deployments are powered by Lorax, which allows us to do dynamic adapter switching. So you have your private deployment. It has your LoRa attached to it that you've trained with your data. So you have it tuned to one problem you're trying to solve. Somebody comes in with a request to one of your other LoRa's, and we can immediately switch to that LoRa without having to restart the deployment, without having to have a long warm-up period. Just instantly switch over, and you're using, from your perspective, both LoRa's essentially simultaneously. Next. And what we found is that using Lorax in this way allows you to rapidly switch between LoRa's with very little overhead on throughput. So we ran this test scaling up to hundreds of LoRa's. We found that in the naive case where you're having to wait for things to spin back up, you're having to switch between deployments to get to each individual LoRa. Your throughput takes a pretty massive hit as the number of LoRa's increases. But with Lorax, because you're working with one deployment, you are just switching the LoRa in place. You can switch between up to hundreds. You can use hundreds with very little overhead on your throughput, with very little hit to your performance. And that is extremely valuable if you're using a wide variety of if you're working with a wide variety of use cases on the same deployment. Next. And just as a final note, we wanted to show how we stack up in terms of latency in our private deployments versus a shared endpoint and DIY serving with LLM. So we ran a test that scaled the QPS against different deployments, and we found that in basically every case, we were in general twice as fast as Fireworks, and much faster than self-serve. So with Predibase, with private deployments, you have the opportunity to get extremely high throughput with both just our hardware and the speculators and other options like FP8 that will improve your model performance, and high model quality with the ability to tailor your LoRa's to your data. So now, really quickly, I'm going to walk through how to set up a private deployment in Predibase in just a few clicks. All right, so here we are in Predibase. We're on our deployments page. We have selected this option here to create a new private serverless deployment. I've given it a name, and I'm going to choose my base model here. We have a wide variety of base models available: LLaMA, Mistral, Gemma, Quinn. So I am going to select LLaMA 3.1 8 billion instruct. Over here, you can select the GPU that you would like to use. Depending on the tenant, depending on the what your plan is, you're going to see different options here. For instance, in VPC, you'll see L4s, but you will, whatever GPUs are available to you, you will be able to select from this list here. I'm going to choose an A100. This doesn't allow quantization, but if I say chose an L40S, you would be able to select FP8 quantization right here. You can create a number of replicas of your deployment. So this allows you to scale to higher workloads dynamically as more requests come in. So if you set this to say to 3 replicas, you would when no requests are coming in, when the deployments aren't being used, they'll scale to 0, saving you money. And as your workload increases, you will scale up to 3 replicas that we will automatically route prompts to parallelize inference. You can also adjust, at which point you scale up. So this would be if you have multiple pending requests at all, then you scale to the next replica. Otherwise, you could say set it to 10. So if you've got a backlog of up to 10, we load another version of your deployment, a replica of your deployment, and start routing requests there. And then to make sure you're managing costs, you can also adjust the amount of time which you scale down. This is by default an hour. You can change it to whatever time frame meets your needs. You can also preload adapters. So let's say you have some adapters trained on the data that you are interested in. You can select a number to automatically download to you and cache on your deployment. And these will be available every time you spin it up. You can also, at prompting time, select a particular adapter to use. If you select one of these, if you say, hey, prompt against my ConLLPP demo 2, then we will use the adapter that already exists on your deployment. If it doesn't, then we'll download it and keep it around in case you decide to use that adapter in the future. You can also specify which speculator to use. So if you select auto, we have a number of speculators, generic speculators that you can apply to your deployment without any additional training. You do not have to use a speculator, so if that's not the right solution for you, you can turn it off. Or you can train your own and choose a custom speculator through here, and that will let you choose one from that you've trained in Predibase. And then we hit deploy, and it will start to initialize. Now, this is going to take some time to get running. So I've had one running for a while to show you that once you've got your deployment up and running, we have a number of tools to help you introspect what's happening, to give you an idea of how your deployment is doing, what the traffic patterns look like, how your throughput and latency are doing. So just here, we can look at the number of requests coming in per second. We can look at the throughput that you're seeing in terms of tokens per second. So you see, as we get more requests in, we're going to be generating more tokens per second, and then eventually that will cap as the requests get larger. You can see what your latency is looking like. So for my requests, the end-to-end latency was on average about 1 second. you can look at the queue duration. So for this particular, so this is how long your requests are sitting in the queue waiting to be processed. For this particular deployment, because I was the only one using it, the queue duration is nearly instantaneous. But if you have, say, multiple sources coming into making requests to your deployment, you can look at the queue duration and use that to decide whether it's time to scale up, add more replicas of your deployment. You can monitor the time to first token, which is giving you an idea of what our again, sort of latency and throughput. Time per output token, speculative decoding hit rate. This did not have a speculator, but if you do, you'll see how accurate your speculator is. And then you can also monitor your replicas uptime. So if you have multiple replicas of your deployment running, you'll be able to look at the usage patterns and see how they are spinning up and spinning down. See how long each replica is staying alive, and that will help you control costs. From a logistical standpoint, when your adapter or when your deployment is scaled down, it takes a little bit of time to bring it back up. So you can look as you're waiting for it to come up, you can watch the event log here and see, okay, so now it's scaling up. We're queued to get a GPU. Okay, we're downloading the weights. You can just see where you are in that spin up process. You'll also see, like, if you make any changes to the adapter or to the deployment by updating the deployment config. That will also show up here. It'll show you any where you are in the update process. In private deployments, you can look at the raw logs here or from your deployment. So you'll be able to see for some amount of time what the deployment is doing, any errors that pop up, as unfortunately sometimes happens. Any errors that pop up, you will be able to get some insight into what's going on here. You can see, for example, as well, that it gives some insight into the tokens per second, the throughput, the generation throughput, some other metrics here, KV cache usage, and that just helps you keep track of the health of your deployment and lets you respond or inform us if something is going wrong. And finally, you can look at how your deployment is configured here, and you can update it with the same interface. So let's say that I have decided that I need to scale down more quickly because there are frequent, the traffic is bursty. We could say drop down the cooldown time to 10 minutes. And that gets reflected here immediately. And what will happen is this will, you'll see that, updating, and it will come back up in a moment. And so that's a quick overview of how to set up a deployment and the observability tools that we have built for you to be able to monitor your deployment. In the event that you need more customization, or you prefer working through Python rather than the UI, we also let you do this in a few lines of code with our SDK. So all you need to do is get your Predibase API token, create a Predibase client, create your deployment with by naming it and giving it some parameters. So in this case, I'm setting up a basic deployment with Quin3 8 billion on an L40S with FP8 quantization, and then to use that deployment, you just create a client by calling your deployment by name, and then prompt it. And it's as easy as that. And there are, if you need more customization, there are a dozen or so more parameters that you can control in the config, around replicas, around cooldown time, around access to third-party services like Hugging Face. You can configure direct ingress through the SDK. So there are a lot of additional knobs you can turn to customize your deployment to make it exactly what you need. So yeah, with that, I'm going to turn it over to Michael, who is going to walk us through a case study.
Yeah, cool. So and I see a lot of questions coming in. Awesome, keep them coming. We're going to jump into Q&A in about 1 to 2 minutes here. So just want to talk about a little bit, we talk about a lot of like, features, theory, things that how it should run. This is just a case in point of what it's like from one of our customers, Checkr, a great company. They use AI to do background checks, classify data and extract it from dozens of different sources, could be education, job background, whatever. And they use that to then create both a portal for employers and employees, so employees can get that information and help them as well, make sure it's authentic and accurate, and then employers to make decisions. They're doing this millions of times a month. They use traditional ML models to classify lots of the records, a lot of unstructured text. But what they found is that 2% of their records that aren't well represented in the broader data set are very complex. And the traditional ML models were not able to accurately classify them. Now you imagine, right, when you're doing background checks, the accuracy is paramount. So you need to do a really good job on processing that data. And that's really important to them. And so they started experimenting with things like OpenAI and a RAG pipeline. They also looked at shared LLMs and trying to fine tune there. But ultimately found is that they were not able to hit both their quality and latency thresholds with either of those options. And so ultimately they ended up using Predibase both to fine tune and serve LLaMA 3AB. So they took this really small model, open source model, put on a dedicated deployment, customized it for their use case, which was these complex data records. And the result of doing that is quite a few things that were really quite promising. One, they saw a 10-point lift in accuracy over their POC or experiments with GPT-4. So saw much better accuracy, which is paramount when doing these background checks. They also, because they had a dedicated deployment, were able to consistently deliver sub-second response times on productions. Their goal is to get their background checks done in 15 minutes or less, and they do that. And so it's really important to have fast turnaround. So they saw 10x plus faster response times in production when they're able to sort of have control of that hardware, right, and using a service like Predibase. And ultimately, they saw 5x cost reduction. So kind of a unique point in time where you can actually get all three, faster, cheaper, and better performance in some of the commercial options. You just have to have the right setup. So that was the Checkr's experience with Predibase. And I'll just leave you with this before we go into Q&A, is that Predibase really is an end-to-end platform for the entire serving through post-training, optimization, and monitoring platform, as Jeff showed. Very robust set of capabilities, truly built around making it easy for you to build true production use cases with open source AI. If you're serious about production use cases, we're here to help you. We take away all the ugly infrastructure pain and make it easy to customize your models, easy to serve them at very high throughput. So with that, let's get into the Q&A. I'll leave this up so if folks are interested in either talking to one of our AI engineers afterwards, do a custom demo, or try the platform, get free credits. You can go to any of those 2 links and get that. So I see Jeffrey is still on. Joseph, are you still there? Can get you back on the camera. There we go.
So there.
Got the SWAT team. I know Joseph's been answering some of these questions in chat and what have you, and in the Q&A. So keep your questions coming, but I'll probably just jump right in. One question I thought was interesting, because I actually don't know the answer, is Jeffrey, how big are speculators? What is the size of those models?
Sorry, I was muted there. Yeah, the speculators are negligibly small. The exact size is related to the size of your LLM, like LM head, but they do not add enough overhead to say really generally push you over the line on your GPU or make downloading, rolling them out prohibitively expensive. So very, very small.
So what you're telling me is that So I get all the benefit without any sort of additional gain. That's what you're saying. Okay. Or any requirements really on the compute side.
Yeah.
I saw you were answering one, actually, Joseph. Yeah, someone was asking, can you bring models from Unsloth? I think it's a broader question. It's just, can you bring your own models? Do we have limited support for models? Thoughts on that, Joseph, since you're already answering it?
Yeah, I mean, we support deploying any model that is hosted on Hugging Face. Some are easier to host than others, depending on how non-standard configurable they are. But by and large, if there's a path to it on Hugging Face and you have an API token that can access it, we can host it.
Nice. So bring your model, any model you want. We have first-party support for many models, but any model you really want, we can support. So if you fine-tune it elsewhere, great. And you want best-in-class infrastructure, we got you. Oh, there was some question I saw you answer, Joseph, around speculation, and Jeff, feel free to jump in as well. Someone's sort of asking, can you elaborate a little bit if you stream tokens ahead of time? What if they change as the model progresses? Can you speak to that a little bit?
Yeah, so with speculation, we actually have a verification process. So it's sort of a two-pass process of generate tokens and then verify that that they are correct. This is based on using log probs under the hood, but basically we have accept and reject criteria, and if the whole series of speculated tokens is accepted, we return all the speculated tokens. If they do not pass that threshold, then you only get the next token, right? So if there's a lot of uncertainty, you're not going to get incorrect tokens back from the deployment, from the speculator. We're going to fall back to just using the originally predicted next token.
Nice. Thanks for the explanation. Another question came in. Someone was asking us about sort of how we deploy our deployment. Where's our SaaS deployed? Do we support other clouds? How does that kind of VPC direct ingress? Maybe you just want to speak to that a little bit. Either one of you can feel free.
Sorry, I was answering a
Yeah.
different. Which the question?
Oh yeah, just about our deployment. Are we, do we? Someone say, hey, I assume you guys don't have your own data centers, so are you deployed on a hyperscaler? How does that work? Do we support different ones?
Yeah, so Predibase has access to several different data centers that provide GPUs from different providers, which we lease and manage. In the VPC case, we're actually it's your own GPUs that you're bringing that we're managing. I'm not sure what else there is to the question.
Yeah, so I think the TLDR here is our SaaS and cloud lives in AWS, but we can definitely deploy VPC in any of the major hyperscalers. So if you're in Azure, GCP, AWS, we can deploy there, and we have the direct ingress with AWS. So broad support. Let's see. Someone asked, oh, it's pretty simple. Do we deploy, is the open source LLM hosted in Predibase tenant or somewhere else like Hugging Face? It would be shared, would be hosted in our tenant, and then a VPC would be hosted in your tenant, right? I think you already said that, Jeffrey.
Yeah. Yeah, that's exactly right.
Let's see what else we got here. Going through the questions. Someone asked about open source serving. Maybe you want, Joseph, I saw you wrote a response. Maybe I have some thoughts, but maybe want to give some thoughts on open source serving tools and yeah.
I think I may have answered that one.
Oh, sorry, mixed you guys up. Yeah, go ahead.
So yeah, I personally like VLLM a lot for this. It's pretty easy to spin up a deployment. Yeah, if I'm just playing around with LLMs, that is my go-to choice. Obviously I use Predibase myself for most of my LLM inquiries, but yeah, just as a lightweight solution to serving, you can use VLLM. In that case, though, you just remember that you're on the hook for every aspect of the deployment. So acquiring hardware, making sure that you can reach the deployment, any issues that come up here, that's you're on the hook for resolving those. And through Predibase, we handle all of that for you.
Yeah, I think if those folks recall earlier, not only is it a pain of managing it, trying to do things like speculation that many don't know how to do, but also if you remember the charts earlier, VLM in our benchmarks, and we just published a blog about this as well, was typically 3 to 4x slower. So if you're doing a production job where throughput or latency matters, you're going to need to look at oftentimes a managed solution. Someone asked about FedRAMP. We are not FedRAMP certified. We do have SOC 2 Type 2 certification, and through like VPC and then BAAs with like AWS as an example, we can support things like HIPAA workloads. FedRAMP is not on the short-term roadmap, but something that obviously we're always looking at. Let's see. How might you compare Predibase? Maybe a tricky one, Jeff or Joseph. If you'll chime in. How would you compare like a Predibase to like a Grok or a Hugging Face?
That is actually a good question. I don't have on hand just a good analysis there, but I'm happy to do some work there for you and get an answer back.
I don't know, Joseph, you have any thoughts off the cuff comparing to others?
Yeah,
Like Hugging Face. Okay.
I've done a ton of competitor analysis against Grok and Hugging Face for inference, so I don't have a pat answer for that. I'm sorry.
Sure. Someone had asked, how focused are you on long-term and cost latency throughput reduction of fine tuning? Much this was on inference. So how do we think about fine tuning? I know we've done some pretty novel stuff there. We have incredible stack. Maybe you want to talk about that as well.
Yeah, maybe.
Go ahead.
I think I mean, my high level is like actually as a company, we put a ton of work into fine tuning. Until recently, that's been like the differentiator that we focused on is our high quality training platform. Like recently, we introduced RFT fine training on. I suppose that's redundant. RFT on our platform. We were the first company that offered that as an easy to use service. And previous to that, we offered different fine tuning techniques. So it's actually pretty fundamental and core to our value proposition. And in fact, a lot of the things we talked about in this presentation, talking about how you can get comparable performance with like LLaMA 3.1 against GPT-4o, rely on the fact that you can do fine tuning very easily on a platform to improve the quality of your predictions.
Yeah, and building on that, fine tuning is always going to be a very important part of Predibase. You fine tune to get speculators. You fine tune to get Lorax, right? You can do SFT or RFT to train your model in different ways, right? And we are committed to supporting that and improving that process as much as we can, maintaining a high quality of fine tuning offerings.
Nice. Thanks, guys. Someone was asking about sort of diving a bit deeper on the cost analysis. Joseph, I passed you over a sec because I know you wrote some thoughts on this. And they're mentioning like a startup. I think like it does really depend where you are in the maturity and life cycle. If you are early days, low traffic, you're not quite at a production use case, you may not need something super robust. So you got to really think about like, are we still in experimentation? But once you get to production at scale, is when you really need to have a solution that is robust, right? That can handle those workloads, that give you the capabilities you need to manage them. And so I don't know if you want to expand on that, Joseph. They also asked about, do we offer like token limits or some sort of limits if you're a smaller company? So maybe you can speak to that.
Yeah, I mean, I would say like dedicated deployments are not always the right answer. Like if you are super low, like if you really are just doing like, a few dozen requests or whatever like that, then like a shared serverless deployment really does make sense for you. Like just paying, a few cents for a few tokens is probably a much lightweight, easier solution. But like if you have any level of volume, at some point, like it doesn't take long before a dedicated deployment starts to make sense. And the cost analysis that I put in that graph is like we're talking millions of dollars for like hundreds of QPS. And that's a pretty high volume use case. But like single GPU, single LLMs, single replica LLMs cost on the order of like dollars per hour to use. Like it is not expensive, and you're only paying for the dollars for the hours where your deployment is actually doing work. If it spins down to zero because you have no traffic, you're not paying anything. So if you're an ultra low consumer, like an ultra low token usage consumer, then yeah, probably stick with shared serverless deployments. But if you're looking at, a few QPS, like it's getting to the point where a dedicated deployment really will make sense.
And just to give additional context, we have a shared offering for people who are like kind of that early phase. And honestly, like we work with companies of all sizes, large billion-dollar, Fortune 500 enterprises to early stage startups that are 10 people. And not every sort of private deployment is a six-figure deployment, right? We have customers that are like in, the low double-digit thousands as an example. So it really depends. There's package, sort of offerings for startups as well, earlier stage. I think again to Joseph's point, you really want to make sure like you are at that like getting a couple QPS before it starts to make sense. So if you're really just an experimentation, then yeah, like low end, then that's where you should play. I see we're pretty much at the top of or bottom of the hour here. We're wrapping up. Want to thank everybody for joining us today. We had a great session. It was a lot of fun, a lot of great dialogue, questions coming in. I think we got to all the questions. Joseph and Jeff were pretty active in there. If we missed one, please send either of us email, just our name at Predibase, first name at Predibase, or you can find us on LinkedIn. And just want to thank our great speakers for all that they ran through today. And we'll see you in a few weeks for the next one. So I hope you had fun. Thanks, everybody.
It's a pleasure. Thanks a lot for the great questions.
Thanks.